This is AWR Microwave Office tutorial series. In this video, we will use manufacturer's SPICE model, datasheet, and package parasitics to model a diode from scratch. And we are going to use this model in the upcoming videos of diode mixer design. So let's get started. In the first step of this video, we are going to open AWR design environment. Let's create a new schematic. To do that, we'll go to circuit schematic, right click, new schematic. We are going to name it diode model and click over create button. Once the schematic has been created, we'll go to elements, go to non-linear models. From here we'll select diode and let's place SPICE non-geometric junction diode in the schematic. We are going to place it somewhere here. Now in this diode model, we are going to add the parameters from the SPICE model provided by the manufacturer. Okay, this is one way of doing things. There's another way. We can place the sub-circuit here, import the SPICE model as we have already done in previous tutorials, right? So here we are just going to add all the parameters manually. To do that, we'll just go back to the folder which you can download using the link given in the description. From here we'll go to the SPICE model of diode and here you'll find the D315V7 model. We'll just open it on Notepad. And we are going to enter these parameters into the schematic. Alright, so I'm going to do that quickly. Now after adding all the parameters on this diode model, we are going to add package parasitics. To do that, again we will go back to the same folder and there you'll find this SOD323.txt file. If you'll open that on Notepad, you can see here we have the package parasitics. So this is our actual diode where we have added all the parameters, and in that diode there is some series inductors, parallel capacitors. So we have to add those to make our diode model more accurate. And here we have all the values as per those package parasitics. So we are going to add these package parasitics first. So I'm just going to close this, go back to AWR, and to add the package parasitics or to add the components, we'll just hit Ctrl L on our keyboard and we'll search for inductor here. Replace one inductor which will be in series with diode. We'll just Ctrl C, Ctrl V. There will be one more inductor, Ctrl C, Ctrl V. Another inductor will be at the cathode of the diode. Then we have to add one capacitor. So go back to the library, search for capacitor, click on OK, and that will be parallel to the diode. We are going to just click over this zoom fit button. Here we go. Now I'm going to enter the values from the parasitics model shared by the manufacturers. To do that, we'll just add these equations. So the LAO value was 0.65. I'll just copy this, Ctrl C, Ctrl V. Then another parameter was LAI and the value was 0.76, and these all values will be in nanohenry. So just remember that. Then there will be another variable which will be LCO and the value of that will be 0.6 nanohenry. And then there was another capacitor. So I'm just going to place it here and the variable name was CAC and its value was 0.12 picofarad. Here we go. Now we are going to assign these variables. So let's place those somewhere here so we can see that. Okay. Now we are going to assign these variables to these inductors. So this will be LAO. This will be CAC. The name of this variable is LAI. So let's make that. And this will be LCO. Here we go. Next we are going to add the input and output port before running the simulation. Now to add the port, we'll just click over this port button from the toolbar. We'll place it here. Right click, Ctrl C, Ctrl V, rotate the port. Let's place this text here. And then we are going to connect these components as well. All right. So here we have our diode model with package parasitics. For this port, So since this will be the anode of the diode, so I'm just going to change the port ID to anode here. And similarly, I'm going to add the port ID for another port. Let's make it cathode. So as of now, our diode model is ready. In the next step of this video, we are going to prepare the diode model for IV curve test bench. All right. Now to do that, we are going to create another schematic. So let's right click, create new schematic. I'm going to name it diode IV curve and click over create button. Next, we are going to place the sub-circuit of the diode model that we have created. To do that, we'll just click over here, and this is the 2-port model that we are going to use. So we'll place it here. This is anode and cathode, and we are going to assign the diode model on this rectangular block. To do that, we'll double click, go to symbol, and here we have to find the diode IC. So let's scroll down, and here we go. Click over OK. So we have assigned the correct symbol to this sub-circuit block. Now we are going to add the ground at the cathode side. And next we are going to place the measurement device, which is IV curve. To do that, we'll again go back to library. And here we are going to search for IV curve. So let's search. Okay, this is the one that we are going to use. We'll place it somewhere here. Next, we are going to change the value. So stop voltage will be 1 volt, and the step size, let's make it 0.1 volt. And let all the other parameters as by default. We are going to connect the sweep port to the anode of the diode. And the step, we are not going to set any step externally. So we'll just let it be like that. In the next step of this video, we are going to create the new graph. To do that, we'll click over graph, new graph. Make sure you have selected rectangular here. Click over create button. Next, we are going to add measurements. To do that, we'll click over add measurements. Go to non-linear measurements. And here we have to select current, and in the measurement, we have to select IV curve, which is here. So as you can see in the description, this will plot for IV curve trace, I at the sweep terminal. Make sure you have to select the correct data source name. So in our case, it will be diode IV curve. Make the IV curve step to 0 volt and click over add and close it. And we are good to go for running the simulation. To do that, we'll just click over this simulate button. All right. So here we have the IV curve for the diode. And to verify that, we'll open the data sheet of the diode. So from the data sheet, we are going to verify the forward voltage at a particular forward current. So to do that, we are going to add the marker, and we are going to add marker at 1 milliamps of current, and then we'll see what is the voltage at 1 milliamps of current. So for now, just add the marker here. We'll double click here, and we'll right click over marker, click over marker search. We are going to find the value on y-axis, and let's search the value, let's say 1 milliamp, and click over search. Okay, so as you can see, at 1 milliamp, the forward voltage is 0.2366, which is sort of between the minimum and the maximum value of the forward voltage given on the data sheet, as you can see on your screen, and it is very close to the typical value. Similarly, I want to search for 10 milliamps. So as you can see, at 10 milliamp, the value is 0.3685 volt, and which is again close to the typical value given on the data sheet. All right. So we have modeled the BAT15 diode, which acts like a real diode. Now in the next tutorial, we are going to use these diodes in single diode mixers, and we'll see the simulation results of that mixer. Next, we are going to save the project. To do that, first we'll just cancel this. Go to File, Save Project. I'm going to save it on desktop. Save button. For more tutorials, visit us at resources.emaeda.com, and don't forget to like and subscribe our YouTube channel.